Use the following equations to answer the questions that follow. Alright, well there's A. Examine each of the equations above. Circle the equations that are equivalent. Think about the structure of the expressions on the left side of the equation. It may help to draw a model of each equation. Okay. Well, let's just take a look at these and see how we can split them up. Like these. This first one, it could be split up into like a 1/2 kind of a distribution problem, like these. Equals 5. Alright. We're kind of factoring out that half from the denominator. Another way we could write it is just by splitting up the fraction into two separate fractions, which would be x halves plus 3 halves equals a 5er, and that would be good. Or you could split this up from here and just make that a 1/2 x, and then plus the other 3 halves equals 5. So let's see if there's any of these other ones that are equivalent to this. Bam, it looks like this one is right here, and then this one in red is right here. So there we go. And that means that this one has no other matches. One of the reasons why we kind of show it like this is, I don't know, it kind of does simplify the problem. But some people prefer to see the two fractions. Just remember, if we have common denominators, we can change that into one fraction, though. So if we started here, and then we could change it to this with the common denominator. B, solve each of the equations in the space above. Did you find that some equations were easier to solve than others? Why or why not? So number 1, up in here. Well, what would you guys do? Yes?
I would divide the 5 by 2, or multiply it by a half, and then subtract 3 from it.
Okay, you're on the right track there, yes.
Wouldn't you multiply each side by 2?
Yeah, we gotta multiply this by 2 on both sides. Why do we multiply by 2? Bam, cancel out the denominator there, 2's. Some people consider this finding common denominators because, in other words, we can get rid of this garbage right here. And if we divide, well, 5 is really just 5 over 1. So if we multiply the 1 by 2 and the 5 by 2, that gives us 10 halves. Once we have common denominators, then we can ignore them and make this x plus 3 equals 10. And then, yes, we would subtract the 3 from both sides of the equal sign, and we get x equals a 7. Well, let's check then. Does 7 plus 3 divided by 2 equals 5? Yes. Because that'd be 10 over 2, which is 5. All right. So where did that x plus 3 over 10 come from? Well, I guess I kind of skipped a step there. So once we multiplied the 2 by the 5 and the 1 right here, then we had x plus 3 over 2, and that would then equal 5 times 2 is 10, over 1 times 2 is 2. That gave us the common denominator, so really we just kind of get to ignore those denominators, and that's where this equation came from. So several of you said you would distribute that 1/2 first. However, it's not really necessary that we distribute that 1/2. We can kind of do the same thing we were going to do in that last problem, where we could multiply this by 2, but we just have to multiply the 5 by 2 as well. Because if we do it to one side, we should do it to the other side of the equal sign as well. And what does that do? Well, 2 times 1/2, this gives us a 1. And then we have the x plus 3, right? Equals 5 times 2 is 10. Well, 1 times x plus 3, that's just going to give us itself, so we can get rid of the 1. Now we've got x plus 3 equals 10, which we've already done by subtracting 3 from both sides. We get x equals 7. And that's what we should have found, because this is one of those 3 that we thought were equivalent. Now on the other hand, if you had distributed the 1/2, here's what would happen is you would just get this next equation. and then you'd be at this point, okay? So how do we solve this one? Well, it depends on how you want to look at it. You could change this back into a single fraction, making that x plus 3 all over 2 equals 5. Or you could solve this by finding all common denominators. So again, we would say that's 5 over 1. And the denominator we want is 2. So we'd have to multiply the 1 by 2, so we'll have to multiply the 5 by 2. Notice 2 over 2 is 1, so we're not really changing the value of 5. And we all know that 10 over 2 is, well, 5. So that gives us x over 2 plus 3 over 2 equals 10 over 2. And since we have common denominators, we can ignore them, which would then give us x plus 3 equal 10, which we've done already, right? Minus 3 from both sides. And we find that x equals 7. Alright, so this is the one that we said is different. So, and there are several ways we could solve this one. For example, you could find common denominators for each. But since the 3 is common, is a like term with the 5 rather, we could just subtract the 3 from both sides, like this. And then we've got the x over 2 equals 2. And then we can multiply both sides by 2, which makes these cancel out, and you've got x equals 4. Bam. So what the heck is the deal with this? Well, you're going to see these organized very differently. And as it turns out, well, these ones have fractions. And we didn't do very many with fractions before, which is why we're introducing them now. And so it is important for you to understand that the way that we see a fraction, for example, like this first one, we could split it up into these other, well, the other 3 that we used. This one as well can be split up, and this one can be split up. We can write them differently so that if we like to solve them a certain way, we can change them into a very specific form. So let's solve these. We'll just use whatever method we want. So we'll leave that up to you guys. There you go.
Okay. So, not sure if this is right or not, but so I multiplied it by each side by 4, and then so you get 24. Then you add 1, you get x equals 25.
Alright, so what happened to that 4 in the denominator from the beginning?
You asking me? It was divided, but then we multiplied it, and then it disappeared.
Very good. So they do cancel out, right?
Yep.
Excellent. Well, let's check real quick, okay, because we can do this one pretty quick, right? You got 25 minus 1 would give us the 24, which is kind of what this was showing. And then if we divide that by 4, we do get 6. Bam, checks off. All right.
Well, I don't know. This wasn't really following the steps they gave us, but I subtracted this from this, so this would be 6/4, and so this right here should equal 6/4. So I just simplified that, so that'd be 3 seconds, and then 3 seconds, or 3, yeah. Is that good? Or
Okay.
is x equals 3?
All right. Well, thanks. Yeah. Let's show a little bit more work on that, though. Okay. I mean, you did a great job. Let's just show some work on that. So, what he's saying is we're going to subtract the 1/4 from both sides, right? And since that's common denominators on the right side, these 1/4 is going to cancel out. That would give us x halves equals, well, 7 minus 1 is the 6. And then the common denominator is 4. And then we can reduce this by 2 each, which will turn out great because then we got x halves equals 3 halves, right? And so since we have common denominators now, we can ignore them. And then this would give us x equals 3. Very nice. All right, there's another way that we can look at this, though. So let's take a gander at that. So this is our problem that we started with. If we wanted to, we could make them all common denominators and then ignore all of them, which means we need to multiply the 2 by 2 and then the x by 2. So this gives us 2x over 4 now. And then this is plus 1/4 equals the 7/4. But since we have all common denominators, we can, again, ignore those. So we just get rid of them. Then you got 2x plus 1 equals 7. Subtract 1 divided by 2 and you get the same exact answer that we had there. There we go.
So, first thing that I think would happen is you take the 2x over 3, 14 over 3, and you times,
There you go.
and this would become 2x plus 4 equals 14. Then you subtract 4 from both sides. And you end up with 2x equals 10. And you divide each side by 2. And x equals 5. Any questions?
Hold on, though, Gavin. We'll come to you in a sec, okay? Let's check this thing, all right? So up here we got 2x over 3 plus 4 should equal 14/3. So if x is 5, then we got 2 times 5, which is 10, over 3 plus 4, right? It needs to equal 14/3. Not 4, just 4. Well, we need common denominators to add those two, the 10/3 and the 4. So let's go ahead and give ourselves common denominators. Right now that's 4 over 1. So we're going to need to multiply the 4 and the 1 by 3. So we got 10/3 plus 12/3, which would equal 22/3, right? So this one right now doesn't equal the 14/3. That's okay. We just need to go back and figure out what happened, right? And that's why I'm a little cautious on this method, even though it's very highly used, okay? So we got to be careful. If we multiply any of the terms by the same thing, we got to multiply all of the terms by the same thing. So in other words, we just need to come back up here and multiply the 4 by 3. All that's going to do is you're going to change this 4 to now it should be a 12. And then we're also not subtracting 4 from both sides. We would be subtracting 12. And so yeah, it does change this one as well. 14 minus 12 becomes a 2. And then 2 over 2 becomes 1, right? 1. And we could check this one, or we should be able to check this one. Once again, if we come back up here, 2 times 1, up here we're going to change that 10 to a 2. So this 10 is a 2. 2/3 plus 12/3, that does equal 14/3. And therefore we know that this one now checks off. So x is 1. Bam, there we go.
So you want to subtract what? This 1/5 from this side and from this side. So you'd get 4. Bleh, that's not it. Sorry. Nope. How do you erase? Oh, I see the eraser. Okay.
Nice.
Now we're back to that one. Yeah. Okay. So it would actually be 3/5. It's a lot bigger now. Okay. And equals 3x. And then you divide by 3 and divide by 3 and think you get 1/5 if I did that correctly. Did I do that right?
That's what I got.
Did you do it right?
I got 1/5 and I checked my
Okay, well good.
Oh,
yeah.
cool. Then I did
Yeah, checked it.
it. Yay.
And that way we can know, right?
Yeah.
Alright, very good. So just real quick, and this just is a kind of review for you guys. All right, we got the 3/5. This would be divided by 3, like she's shown there. Now we'll make that 3 over 1. If we switch this to multiplication, we'll just reciprocate the divisor and make that a 1/3. And some people would say would cross simplify right there, which would give us the 1/5. Let's do that. So this only works because we're not adding or subtracting anything here. Like if it was 1 plus this stuff, or even like a 1x plus that stuff, we wouldn't be able to do this. So, okay, whatever. So let's go ahead and multiply by 3 on both sides. Only because this is one of those special scenarios when we can. So 3 times 1/3, these are going to cancel out, which gives us the 1, right? And we got the 2x minus 4. This equals negative 6 times 3, which is negative 18. That's pretty good. And since we're multiplying that by 1, the product of that is just itself. And so we can add 4 to both sides. And now we've got this 2x equals a negative 14. Bam. So close, we just got to divide both sides by 2. So the 2's cancel out and become a 1x equals negative 7. That's it. And we could check this, right? 2 times negative 7 is negative 14, which was shown right here. And then minus 4, that's the negative 18, which is shown right here. And then times 1/3, bam, negative 6. There you go. There you go.
Alright, so first you want to times each side by 3 to get rid of this 3, and then this cancels out, and then you have negative 2x plus negative 5 equals 9. And then you can add 5 to both sides. And then you have negative 2x equals 14. And then divided by negative 2, divided by negative 2, and then x equals negative 7.
Alright. There you go. So let's come back here and check, right? So negative 2 times negative 7 is 14. Minus 5 is 9. Divided by 3 is 3, right? So that does check out right up in here. This one is a slightly bit different, so I'll do this one for you guys. So we have the 3 different denominators on this one. However, 12 is a multiple of 3 and 4. So if we can just multiply 3 by something and then 4 by something to get 12, then we'll multiply the numerators by the same number, and then we'll have common denominators throughout, okay, which will allow us to get rid of them. So 3 would have to be multiplied by 4, which would then give us a 12th. But I've got to multiply the 1 by 4 as well, so we got 4/12 there. Notice again that these are equivalent fractions, which is why we're able to do this. And then this should equal 4. We're going to multiply that by 3, so the 1 by 3 as well. That's 3/12. And of course this was plus the x/12. So we have common denominators throughout, which is great. Whatever. Alright, let's continue with this thing. Alright, so we're going to ignore all the denominators. So we got x plus 4 equals, now that's a 3. This equation in purple no longer has denominators, which, well, we kind of hate because it's a fraction, right? So let's go ahead and subtract 4 from both sides so that we can get that x all by itself, meaning that we would just have x equals something. 3 minus 4 is negative 1. Bam, there we go. And if we check this, we should get the same thing. So this would be a negative 1 up in count. And then we could kind of replace it here too. So negative 1/12 plus 4/12, bam, it does equal 3/12 or 1/4. So up here again, just with this idea of the fractions, we're scaling them up or down, but they're still proportional, so they're equivalent fractions. Alright, thank you.
So you need to get rid of the denominator, so you multiply by 3. You get negative 18 equals 3x minus 12. And you add 12. and that is 6.
So bad.
He turns around all fast and goes.
Oh, second to ceiling.
That's like never.
Just like giant grill.
Thank you. Here's what I'm going to do on this one. I'm going to distribute that 1/2 instead of multiply by 2, even though you could, right? So 1/2 times 4x, that's, I'm just showing you this because it's extremely convenient, right? So 1/2 times 4x is 2x, and then plus 1/2 times 12, bam, 6. And this should equal 2. And this now is just a 2-step equation. Subtract 6 from both sides. And we get the 2x equals -4. And then divide both sides by 2. And x equals a -2. Which we can check. So 4 times -2 is -8. Plus 12 is 4. 1/2 times 4 is 2. Alright, there's all 9 of those. Alright, write a story that goes with the expressions and equation in each problem. Solve for the unknown information. Interpret your answer. So, the number of people at a birthday party, P. The cost of a party at Boondocks is 8P plus 60. And then Rage and Waters is 20P. 8P plus 60 equals 20P. So, our story, we'll just say is you. You are planning a party. And at your party will be P number of peoples. Actually, I'm not going to write that in. I'm going to skip all the way here to the bottom. So that's 8P plus 60 equals 20P. So let's identify Boondocks here first. Okay, so Boondocks costs 8 times the number of people plus 60. And then we got old Rage and Waters, which is going to just charge us $20 per every person. Yeah, so that 8P plus 60, that'd be $8 per person. And then plus a $60 some kind of fee. So let's write in Rage and Waters. And then we're down there at the bottom with this equation, which really is just asking, since they're equal, how many people would we need to have at the party for Rage and Waters and Boondocks to be equal. Bam, there we go. There's our story. Now it says to solve the equation. Let's get a little bit closer to there then. So solving this one, not too bad. I'm going to subtract 8P from both sides. Then I got 60 equals 12P. And then divide both sides by 12. Bam, we find that P equals a 5. So this is the answer for this one. But we need to interpret it. That's what it wanted us to do. So for 5 people, the cost is the same. Bam. All right, any questions on this one? I don't think that was too bad. All right, now we're looking at some savings. The number of weeks is W. Sophie's money is 300 minus 40W. And Raphael's money is 180 plus 20W. So Sophie, is she saving or spending? Spending. How do we know? Yep, we got that minus right here. What about Raphael?
He's making money.
Looks like he's making or saving money. Particularly 20 every week. Sophie is spending 40 every week because it's 40 times the W. And Raphael is 20 times the W. So let's go ahead and write in a story. Alright, let's put that in there. So, let's start with Sophie. Sophie, let's start with that 300. Sophie has $300. So Sophie has $300. And since she's subtracting, she's spending looks like $40. $40 every week. Because it's 40 times the weeks. On the other hand, we have old Raffy. Raphael has $180. and is saving, or what was it, what we said there? Gaining, yeah, gaining $20 per week. So that takes care of those two expressions, but then at the bottom there, notice they are equal. So the question would be, after how many weeks do they have the same amount of money? Bam, there we go. That may help us see the story better, but it says to solve the equation, so actually that's in a bad spot. So let's solve the equation. Now when we solve this, we'll know W, and that'll tell us the number of weeks that their monies were the same. So let's put all the W's on the right side then. I'm going to add 40W to both sides. So these ones cancel out. We got this 300 equals a good old 180. This, oh, that's not. Plus 60W. Then we're going to subtract 180 from both sides. And 300 minus 180, that should give us a 120 equals good old 60W. And then we'll just divide both sides by 60 to get our answer. W equals 2. So after 2 weeks, they have the same amount of money. Bam.